In this example, we're going to show how to take analysis data and using convergent modeling, make it into a usable part. This is data that is potentially created by an analysis person, and it's not in very good shape. It's all STL data, even though these look like they're cylinders. They're not. They're STL data, which we imported as a NX convergent body. And that gives us the ability to work on this data. So what we're going to do is we're going to, first, we will clean up this data. So we're going to hide the existing data and work on just this part of the file. So what we'll do is we'll go into our polygon modeling, which is convergent modeling, part of convergent modeling, and we're going to smoothen out this data. So if I grab the data and I am going to leave it at 1 for the smoothness factor, but I'm going to change the iterations and I'm going to smooth over face edges and kind of see what type of result we get. And we can always smoothen it more. So it's fairly good. Maybe we'll do just a little tiny bit more. Try to get a nicer looking surface. So it's starting to get to be a good looking surface, but we have some problems. There's definitely some problems, but easy to fix. What we could do is come into snip and we'll use rough brush, and we're going to get rid of the problemed areas. We're going to get rid of that. We're going to get rid of that. And these areas here to me are concerning, so we're going to get rid of them also. And we're going to recreate these areas. Now areas like this, we could come back and smoothen at a later time. Now this area here. We will just get rid of all of them. So they're kind of pointy. They're just not a desirable look. Okay, so I just snipped all the areas that I can see. There may be some others, but I think we're good for now. So this is the part I care about. The rest of it is all kind of like space dust sitting out there, so I'm just going to simply delete them. Now I have the part that's important, and we could come in, we could fill these holes. And I'm going to do all of them at the same time, and I'm going to make them, I could make them linear all the way up to curvature based, and I'm going to make them tangent, something just nice tangency. And I am going to rectangle them. And then we'll hit OK. So now we have kind of our fixed area. And we can even come back and do more smoothing routines. So if I wanted to smoothen this, maybe smoothen it up a little bit, I can do that. So now I have a convergent solid body that is smooth. And we can go and work on the other portions of the model at this point. So what we're going to do is we're going to use our mixed modeling. And how that works is we have a command called replace mesh with face. So we can replace these, and I want to make these actual cylinders. Right now they are not cylinders. They're just part of the faceted data. So these are all going to be cylindrical now. And then I want the other sides to be planar. So these will actually go from faceted data to planar data, planar faces. So there I've selected all of them. And now that we have that, we can do more modeling. These are actual cylindrical faces now. When I select them, that's a actual cylindrical face. And because we have that, we can do our mixed modeling. So we can go into synchronous modeling, and if I show you this, most powerful suite of tools for working on not only NX data, but any data. And I can make changes, so I'm going to grab these faces. And I'll make these, we'll say 22, make them larger so they definitely intersect nicely with the data. And then I will grab these ones and we'll make these 10.3 even. We'll do the same for here, and we'll make these so that they definitely interfere, and maybe we'll make them a little bit larger. And these ones also, and they will be, we'll make them 20. So now we have a parametric model, and all these dimensions can be edited. I just made this 20, let's make it 18. So it's parametric, but a few minutes ago it was faceted data. Now it's real parametric data, and we can even unite this data now, make it a solid. So now it's a solid model. And suppose we don't like the way this looks. So what we could do is we could roll the model back, and because it's mixed modeling, even though it was faceted data just a minute ago, we can do some parametric modeling. So now I have that, and if I roll the model to the end, it's united, and we have our finished model. And we could go on, we could do things like, suppose we want chamfers, so I'll put a chamfer here. And when's the last time you put a chamfer on faceted data? Well, with NX hybrid modeling, it's easy to do. And you can continue your model and designs even though it was faceted modeling. So now we want to add some downstream applications, things like PMI. So PMI will show up in the viewer, in Team Center. It's smart dimensioning. So now that we have a hybrid model, we can easily add the PMI. So if I select this cylinder, so I have that face and then the faces that it is associative to. And then I can place it on the screen. And then possibly I want to do this one also. And place that dimension. So I have some smart dimensioning. And it's because it's a parametric model if I make changes. So let's make a change to this. It's 10.3. Let's make it 12. And the PMI updates with it accordingly. And if I want to make a change to this, it's 18. Let's make it 21. And the PMI updates, and you can see it's associative, and the chamfer updates. So we could add other PMI to the planes and things, but that shows how we can have PMI smart dimensioning to a model that just a few minutes ago was very poor shape from an analysis tool. We were able to smoothen it. We were able to not only divide the faces up into usable parts, but we were able to use hybrid modeling so that we could make them actual cylinders and planes, and that we could put dimensions on them, and we could put PMI. So part of the NX true end-to-end solution.